Hello again, this is Nancy L.T. Hamilton with yet another video. This one is going to be a soldering video, and I wanted to demonstrate all the different types of soldering joints that this ring I created here has. We have sweat soldering with these elements. There's a little element here on the side. Butt soldering, which would be the seam on this ring here. T-soldering, which is this type of solder here. So we have butt, sweat, and T-soldering, and I'm going to show you how to do these. Wacky ring, huh? All right, let's get started. With soldering, there are a couple of really crucial elements that have to be met for your soldering to be successful. One of the first ones is, this is what you do before you solder, is your fit. So the fit, you can't have edges like that. They need to be straight. So when they join, you would hold up to the light, you're not going to see any light coming through this seam here. Something like this, you're going to end up with pieces like this, and the solder may flow in a couple of spots, but it's not going to fill in. The solder doesn't, like soft soldering with a soldering iron, you coat the top of the surface with solder. It's more like glue or tape. Whereas with silver soldering, hard soldering, the solder actually runs up into the molecules in between, and it's a really tight, it's a really strong joint because it pretty much bonds the two edges together. So if these pieces are not fitting together well, they're not going to flow right, and they're not going to join properly. So fit is very important. So take your time on doing your finishing and your edge cleanup and your filing and sanding so that everything is really, really flat. It takes a while to do that, but it's going to make your life so much easier in the long run. The second thing that you really need is cleanliness. See if I can remember to spell it. Solder does not like to flow over dirt. One of the reasons we use flux is because the flux keeps oxidation from occurring. Oxidation occurs when there's copper in something. So sterling silver, brass, bronze, copper itself will produce this oxidation via the copper and it's intermingling with the air. So we want to keep that down because that's dirt, and that's where the flux comes in. So flux is kind of a to be here. To be or not to be. Also greases, oils, dirt, anything will keep the solder from flowing. You'll know if your piece is dirty because your solder will ball up like that. Your solder has to be clean. I sometimes take my sheet, if it's been sitting around for a while, my sheet solder, and I'll hit it with a torch and up to a little less than annealing temperature to burn off any dirt and grease, and then I'll pickle it and dry it and put it into a bag to protect it from oxidation, because that oxidation, once again, is dirt. So cleanliness, wash your hands, don't touch your face. You have a lot of oil glands there. After you've prepped your surfaces for soldering, don't touch them. So that's really important. So once you've got it all together, you need to find a way to stabilize the fit. I hate using binding wire, so I try to make sure that I have really nice clean edges to have. So like if I was soldering a T-solder like this, I would find a way, maybe have cross locks coming off here, something to hold this straight and secure. Magnesia blocks are great because you can stick pins in them and hold things down with them. You can use binding wire, and I actually do that in this video with the ring shank. So find methods to hold your pieces steady, secure, and so that they're very flush on one another, because we're back again to the fit. And then heat. And heat is probably the most important element, but without these, this won't work. You'll just get balled up solder. So the goal is not to melt the solder. The goal is to bring the two pieces of metal up to the same temperature right here at the same time. And that temperature, this is a ball of solder, that temperature is whatever the melting temperature of your solder is. So on a big, so let's say you're doing this, you've got a big square here and you've got a little, let's say, bezel cup here. If you heat this bezel cup, this is going to ball up and turn into a wasted piece of silver or copper or whatever. You always heat the bigger piece, the heavier piece up. With something this tiny on here, you don't even have to heat this, and you'll see as I solder that little bezel, this little bezel here, I don't even put the torch on this. I just heat from behind. So think of the heat that you got to heat up the big pieces first, and this will transfer heat up into this. And then if your solder pallions are like right around here, these two will reach temperature about the same time, and then the solder will flow. Now, when you're soldering, you want to take, here's your solder up against a seam. Let me mention that briefly. You can put the solder on a wall like this, or you can put the solder on the floor like that. Whatever you're doing though, the solder has to be touching both of the surfaces you're going to be soldering. So if you're going to put it on the floor, make sure it's also touching on the wall. If you're going to put on the wall, make sure it's also touching on the floor. It has to touch at least the two surfaces. Okay, so where was I? So if you're heating, let's say you just have a piece of solder here, and I want this solder to run down this seam, what I need to do is heat these two pieces up in this area. Particularly, I generally do a general warming, but then I focus my flame over here. I will heat this area, and then as it melts, I will drag the torch down, and you'll watch as the solder runs down that seam, because the solder will follow the heat. If you're soldering and you find that all your solder flows on one side, that means you did not get your seam heated evenly on both sides. And remember, when you're soldering, don't focus the torch on the solder, focus it on the metal. If I think anything else, I will babble about it, but I think that's generally it for now. And we'll go ahead and start showing you the process. I'm wearing a camera chest holder, so this is a whole new experience. I'm hoping you're going to get a really good view, bird's eye view or Nancy eye view of what I'm doing. So after sawing out your pieces, the next important step is to square everything up. So I've got a back plate here, which is this. Then I've got my half dome, which is basically a circle that I just cut in half. I have to prep my little applique pieces here, and I need to square up my ends of my ring shank here because they're pretty funky. So, and I also have this little other piece that's going to go across here. So what I need to do is, I like to use a miter cutting vise because you can get really nice square edges. The deal with these is that one side has to be perfectly square and even. So I usually use the metal that I get as I get it from Rio Grande or wherever I get it, that has a nicely machined square edge on it. Like this edge here is the machined edge. So that always goes against the pin right there, and it goes really flush. You don't want to see any little black lines, which shows that the metal isn't totally pushed up against that pin on both sides. I do have some information on my website about using this tool. So I'm going to file all my pieces down, and I'm also going to, where did my square go? I'm going to check the fit on all of them to make sure that they're square. They should sit like that with no light showing on the bottom or the side. So we know that corner is a 90-degree angle. So we want to do that. And then after filing, you want to take sandpaper, and I tape the sandpaper down here and drag, because if you're using really rough file, what it does is it makes these, let's see if I can grab a pen without wiggling too much. This is very good for your posture, by the way, using this chest cam. So when you file with a rough file, you leave marks like that, right? So we want to smooth it down as much as possible because that helps us get a better solder join, because if you're trying to do like this, you're not going to have a nice seam. You also want to take any burrs that have formed along these edges here off, and you don't want to sand the metal in this direction. You want it to be absolutely flat on the sanding. So I like to just take it and drag it along something flat and just enough to take off the burrs. Otherwise, what can happen is you can create this. I should draw another picture for you. So if you take, so here's your proposed join for your ring shank or whatever you're soldering. If you, oh, and you've got burrs like this, if you file at an angle, you'll end up with this seam that looks like that. And you're never, to make it completely invisible, you're going to have to file off all this material up here, which changes the size of your piece, not to mention such a waste of time. So just be very careful when you're cleaning burrs off. I mean, you can use a file and try to go as close to flat as you can. I like the dragging on the sandpaper deal, but you do what you want. Okay, I'm going to go clean up these edges and get back with you. So here we are, ready to solder. I've fluxed, heated the flux, and I've applied solder. I have one pallion of hard solder here on one wall, and the other part's touching this main centerpiece. And then the same with over here. I have a piece here touching the wall there. So now we're going to attempt to solder this. And I'm going to start by heating the entire piece up, not the solder. You know that if you ball up your solder and then apply it, you are burning out some of the zinc and you are reducing its ability to flow. All right, so now we're getting hot. I'm going to move into the seam and I'm going to heat it from the back of the seam because I want the solder to run across. I want it hot, but not so hot that I'm going to melt it. But you don't want to take too long here or your flux stops being effective. All right, I may have to do that again, but that's all I'm going to do for now, and I'm going to pickle that, and then we're going to check our seam and see if we need to apply more solder. Well, it appears like it ran. I've got a little glob there and a glob over here, which I hate because that means I have to clean it up. But the seams look filled. It feels strong and not moving. So we're going to call this done. I'm going to file this level so make sure that all the elements are flush to solder onto the back plate. Now, that's my next project. Okay, what I'm going to do is drag it down my mill file, which is a bastard cut. Really, it is. Wish I could do this. I'll try it left-handed. So I came down twice that direction, so I'm going to, oh, dang, now I'm not sure which way it was. I'm going to do it twice in this direction. It's just all an attempt to get this base nice and flat. So if you can see, it's evenly shiny. So that means all the surfaces are hitting at the same time. And we can also check this by placing it onto the back piece and holding it up to the light to make sure that there's no light shining through. So I can see that I have a really good fit here with no light. So we're ready to, this needs to be cleaned. So I'm going to heat clean it, and then we're going to set it up for soldering onto this back plate here. All right, so my piece is fluxed again. I've carefully lined it up with my center line so that it's in the center, but it isn't. Must have moved when I put the flex on it. This part is worth taking your time over because having to take these off afterwards is a big pain. So I'm going to apply heat. The one concern I have at this point is that the flux could bubble and move my piece. So I'm going to try to hold it down without moving it if I see that happening. And I use my solder pick for that. I'm going to just try to heat it slowly. Also, the solder pick can help ensure that the joint is really tight by pushing it down on the surface. And it helps the flux to hold it. And you want to make sure that you haven't moved out of position. Move this so you can not go out of frame. Okay, we're still at the white stage. We're trying to glass that flux up. That's pretty good. Okay. So now once again, I'm going to use hard solder again. By the way, I also flexed the seams that we soldered earlier just in case those wanted to flow again. I have no objections. So I'm going to put my one pallion on this wall. Ah. Stupid thing likes to hold on to those brushes. It gets hairy sometimes. And then I've got a tiny piece of solder here, so I've got to put one over here. Let's see, so this solder should flow to this side, and this solder should flow to this side. So that means I need solder here and here. I don't even know if you could see that. These are very wildly different in size. I should actually cut one a little bit bigger than the one I have available. There we go. More flux on my brush to essentially coat the solder with flux, and then I'm going to put it on this wall over here. Okay, now we're going in again. I'm going to turn the light off so you can see. Actually, I think I'm going to move this down on the block. Sorry about my big hand there. So I can have this a little more centered. Turn my torch up a hair. Start heating the metal. The bottom piece is bigger than the other. I'm going to heat that the most. And then remember, I'm going to try to heat from the back side on each of these to draw the solder through. See how pink it is? I just saw it flow. Did you see that line of silver? See how the torch is moving in and out? I pull it in, pull it away to see what's happening. I'm not sure that this spot. Alright, I'm going to check this after I pickle it, and hopefully we don't have to do it again. Keep your fingers crossed. So here we are, we're ready to solder the ring shank. I have a really tight join. I can't see any light through it. And then I'm also using binding wire here to keep the tension on the two ends of the shank to further keep it together in case it relax. The metal can relax while heating, and this can open up a little bit. So the last thing to do is I basically just wrapped it around as tight as I could and twisted with pliers. And then I come in and make a little bend here. Oh, without taking it off. And that further tightens down the wire. I'm gonna just hold this. Now I could put this like this and solder it like that. Definitely an option. You can also hold it like this, so you've got your seam down here. I'm probably going to keep it in the cross lock so I can pick it up and heat from underneath, because I'm going to put the solder on the interior surface. Nothing in my house without cat fur on it. Oh my goodness. So I've fluxed the seam. I've already cut my little pallions of solder. I'm going to find my solder pick just in case I'll need that for later. We're going to fire up. Now this is 12 gauge sterling, which is really heavy, so it's going to take a little bit to heat it up. But first I have to warm the flux so that I can put my solder on. Remember, you want to have, your solder needs to have flux on it too. Okay, can we pick up please? Hello? Alright. There goes the solder pick. Alright, right now I'm just going to put that one big pallion on there. And hopefully that'll be sufficient. And let's just go back in here and start cooking. You heat the whole piece. Remember, your cross locks are going to act as the heat sinks, so you might want to heat them so there's not extremes in temperature, cold steel and hot metal. The solder flowed. As you can see, this shiny in there. I'm going to try to pull some of it down here by directing the flame at this end. You want to keep your eye on all parts of the piece at the same time while you're working on it. Check our seam here. I can see solder. I don't know if you can see a little shiny stripe there. So we're going to put this into the pickle and see how things went. When laying out your pallions for sweat soldering on a smaller piece, I would just put the pallions right around the edge. You want to use a lot, but keep it along the edges. In a piece like this, it has a little extra space in the middle. I just run a couple up through the center. The next step after you've applied your pallions is your torch, and we're just going to heat this up. Have your solder pick handy. Sometimes you're able to spread the solder. The goal is to coat the back of this as much as possible. I'm hoping I don't run out of gas. My butane, see how it's balling up? So once it starts to get flat, we want to spread this out as much as possible. You don't want any mountains. There you go. So that's nice and smooth now. So I'm going to pickle that, and then I'm going to sand off the skin and make sure that there's no big lumps on here. And that will help it lie flatter on the piece when you solder it. Here's our piece out of the pickle. As you can see, there aren't big mounds on here. I have some wet dry. I think this is 320. Yeah. And I'm just going to sand down a little bit. This could actually go in the pickle a little longer, but I wanted to film this part. So that's good, and this is ready for attaching to whatever you're going to be soldering it to. If you need to round it, now would be a good time, and try not to touch this side too much so you don't get any dirt on it. Alright, so I've hammered it down. You know, one thing about jewelry making, when you're making jewelry, it is just ugly. You should never let anyone see it while in progress. Because this looks really bad right now, but I know it's going to be okay. I have faith. Alright, heating the ring shank up. Going underneath. Trying to keep my eye open for solder running. I still have that torch tip on the back side. Alright, I saw something. I sweat! I did! Sometimes it takes a couple of solder attempts. And now I'm on the outside. Just pulling that solder all the way through. You want to see a solid line of solder around your applique. So I'm going to call that done. I'm going to double check to make sure that it is what I think it is. And then I'm going to solder the other little teardrop on the other side of the piece. And then we'll meet back here. Have a quick drink or a cup of tea. So I made a tiny bezel for the base of my coral, and I overlapped the wire and then sawed down between the two of them, creating two matching sides. Then they were put together, and then I take the flat nose pliers and squish, so that what happens is that I don't have a surface. Oh, it just fell on the floor, for God's sakes. Always. I want to see the meat like this. I don't want one end higher or lower than the other. And then if you are looking down on it, you want to make sure that they're not like this, that they're lined up perfectly. And once again, you want to look through and make sure you don't see any light. So I'm going to sand that. Well, actually, I think I'm going to heat clean it because I've been woman handling the heck out of it. And I want it clean for the soldering process. So I'm going to do that, and then we're going to put a little solder on our bezel, and we're moving along rapidly. Now we're going to solder our little bezel. I've already fluxed it, heated it, and the pallion is standing straight up for some reason. No comprendo. So we're gonna, this is fine silver, so we need to be, and thin, so we need to be very careful that we don't turn this into a lovely glob. Did it already flow? Usually I wear optimizers during this process because I can't see. I think that flowed. So I'm gonna pickle it because it's dirty. Even though it's fine silver, it's got flux all over it, and the solder has copper in it, so you need to pickle fine silver even if it shouldn't have to be. I re-rounded my bezel so that I could fit my coral in, and it seems to be fitting fine. And I also, using a zero cut Swiss file, drag down its length to clean up and even the bottom, and then I moved to a number 2 Swiss file, and then I used this sanding sponge. You can use sandpaper, like the sandpaper that I used over here on the desk. And then I also found a scrap of metal, and I'm not sure what gauge this is. It doesn't really matter because this piece is going to be soldered onto the ring back. I don't even really need to do a back plate on it because the back plate itself will be the back of the bezel, but since I'm drilling a hole to insert a post and solder a post in, I felt that I would like to have extra thickness of the metal. to accommodate the post. So I cleaned this up with my sandpaper, and also, you know, did the backs of these. And at the same time, you can go ahead and clean off any burrs that are present around the edges from the filing process. I wouldn't worry about finishing at this point. I'll solder this on and then clean it up after the back plate is soldered on. So that's the plan, Stan. So as you can see, I have fluxed, and let's see if I can turn this torch off and see how close I can get here. My solder is in there on the floor. I'm doing that because if I put it on the walls and there's any globs left there, it's a pretty tight fit, and I'll have to clean that solder up. It could interfere with the fit. So I've got space underneath the coral, so I figured I'd put the solder on the floor so any globs will be down there. Also, I made sure it was facing in the correct direction and that my fit was okay before I even did this. I also held down the setting while I heated the flux up so that it adhered and held it to the back plate. So now we're going to solder it. And I'm not using a massively big flame for this because I'm dealing with two thin pieces of metal. And actually, you know what? I think I'm going to use this enameling trivet here. Excuse me while I pick up the piece. I'm going to carefully place it on. And the reason I'm doing that is so that I can heat from behind. I really don't want to apply much heat at all to the bezel itself because it's so thin and it's fine silver, so it's got a different melt temp. I'm also using medium solder for this because of that little bezel. I want this to melt quicker rather than later. It's not level. It's not good. Alright, so I'm going underneath with the flame. And that just heated up really fast. Let's see, is my solder melted? Let's take a look inside. Looks like it. We'll do a hair more. Okay. Oh. Got this camera in my view and I can't see very well with my chest cam. Nancy's chest cam. Alright, so we're going to pickle and check our seam. Don't forget your trivet is really hot. So we'll check the seam and I'll show you a trick I use for testing bezels. Well, I messed up and I forgot to film this part, so I am improvising. One of my favorite ways to check to see if a bezel is fully soldered onto the back plate is to add a little water to it, and I usually use an eyedropper, but I can't find mine anywhere, so I'm improvising with this plastic cup. So all you do is make sure everything is dry. Pretend this is the piece we were working on, and I pour, not like that, I pour water into the bezel cup. And so if I move it over here, I can see that there's no water escaping from it and that the water is still inside. It's kind of cool. It looks like a gemstone. So if you notice that your water level is dropping and it's wet around here, you can check by taking just a little piece of paper towel and putting it next to it. And if you see water absorbing up into it, you know that you've got a leak somewhere. You don't want to have any gaps whatsoever in a bezel. None. Because what happens is they tear while you're setting them. So here you are at the end of your piece. You're almost done. You're setting your stone and the whole thing rips away. It just breaks a woman's heart. And probably a guy's heart too. So anyway, that's a little tip from moi. So sometimes after soldering, like with soldering the ring shank, the pliers become tweezers become distorted. So it's a pretty easy fix. One thing I wanted to say about this is if you don't quench these and let them cool naturally, they're in an annealed state, so they're easier to move. The fast quenching makes them brittle. So if you do this after you've quenched them, there's a potential for them to snap off. You can refile. Use only steel dedicated files for this. You don't want to use your best files for sure. And you can reshape them. And you can keep using them, you know, as far down as you feel comfortable with them being. Once they're reshaped, you can use a grinding wheel too to do that. So what I've done is I've got a piece of steel here that's overhanging on my bench, and it's held on with a C-clamp. And I just take my tweezers and I put them on, you know, clamp them on essentially, and then just hammer down the ends until I get them back together again at the tips. This one needs a little extra. And you can also use a steel hammer, but once again, don't use a funky hammer, one that you don't care about the face of, because the steel hammer will mar that steel up. So there, that's good. So now our crosslocks are back in working order. That's a tip. It was. Well, good job. I hope you learned something today. You can't have enough soldering videos. Soldering is very, very tough. It takes a lot of practice, so give yourself a break and be prepared to melt things. It will happen. So thanks for visiting. See you next time. Ciao.